Sorry, gentlemen, good morning again. Again, back to you this day on February 26, 2021. Last video, which I just was talking to you a few minutes back, was disrupted. So, this is a revised one, another one in continuation of same. This is 276A, and you can see today's another one with same number, same title: Civil Field Engineering Designs, Construction Methods, Contracts, AnnexSL, Organizations, Communications, Coordination, Quantity, Quality, etc. 276A. And this is integral with another one, past one, with which URL is also available here. So, because that was disrupted, I am just continuing and no more explanation further. I was giving example of method statement in that one, and I given method statement about method statement of safety, environment, and will last. Just for reference, I tried to give you. So last minute, 2 or 3 minutes were also lost. So next time when I talk of methods, I'll talk. Now I'm coming back to quality system. Whereas methods I refer to you because it is method, very important one, which we do not take seriously. I have not seen any methods here. People are not even talking of method statements when in construction we deal here. I don't know reason behind that. Why do we not go systematically? Every person is educated in this country. Millions of engineers are working in all fields of engineering, in all branches of engineering. There is no dearth of engineers and there is no dearth of anything. But even then, it's surprising that we boast a lot, but when we find system, yes, there may be documents of quality in company head offices, but when you take care of sites, take care of projects, take care of detailed running, I don't think that we have got something. Based on my personal experience in this country, I can say there's a rush behind rush and then further rush behind that rush. Like sheep crowd, bhed cha. There's that system of sheep crowd is working. It is small project or it's major product, or they copy international systems which they don't understand. They copy them, which is also not correct. No system can be copied. This is what my engineering sense says. Every area of world is different. You have to use knowledge, not copy paste. If I copy something happening in some other country which has got altogether local issues, altogether a different type of infrastructure, and we say we do that, well, I think that's not engineering. That is done without conducting any level of analysis. If you do not understand symptoms, if you do not identify systems and understand what disease one patient got, how can doctor treat that patient? That's the important point here. As an engineer, my patient is bad quality. As an engineer, I can say I am doctor of my work. Doctor not in sense of PhD, doctor in sense of treatment. That I have to treat my problem. That problem exists. That problem is my patient. I have to treat that patient, and I can treat that patient only when I understand what patient is, what symptoms patient is showing, and how it can be treated. That's my job as an engineer. Diagnostic is a must, and diagnostic comes from conducting analysis of whatever problem you have. If you just say, okay, I got this file from USA or England, I'm just copying, paste, changing name of my project, and I'll carry it out. Well, I think that's not way. That's not correct way. When engineering says you have to think on, you have to analyze, you have to find all forces in structure. So we have to conduct analysis on whatever problems we face. If we do not do that, we do not do justice to our profession, as well as we miss justice to ourselves. Copying is not my business as engineer, as well as that's not your business. Copying is not required. Application of mind is required, and application of mind is called thinking power. Power of thinking is required. A power of understanding problem is required. Just we identify this, and we have to identify a problem does exist, and we have to find out solution by conducting analysis where problem lies, why problem lies, what's the root of problem, and then we can say this is solution of that one. Possible solution or optional solutions, alternate solutions, one-off solutions. Like then we can say, and that's very important point. Means we have to understand what is our problem. We have not to understand what is USA problem or what is Europe problem. We have to understand what is our problem and then find solution. Then think on that. If we try to find solution, means we have to think before that number of times. You have to make certain trials also if required for empirical solution. If not, direct answer is available, direct solutions available. It's what is done, what should be done. Otherwise, there is no meaning of once being engineering professional. What's the purpose of your being professional if you cannot think that way? That point must be very, very clear to everybody what we talk of. If I say, I can do this, I would do this, just if I make this statement, without even considering this problem, what problem is? Well, we have to be patient, we have to be intelligent. We are intelligent, of course. We are intelligent by education, indeed. But are we intelligent? How many percent people are intelligent in profession who study everything? I am not going to present anything. I am not interested in any presentation. I have done this, I have this. No, that's not my baby. My baby is different. I have to find solution. If I present something to you, you may understand it, you may not understand it. I may show you many graphics, many, what I have done. That's not my job. My job is to understand and let you understand what is problem, why does this problem exist, how it could happen, and what is its solution. Engineering means solution. If you find someone where is solution provider, so I'm not talking of service provider, I'm talking of solution provider. Because solution provider, solution is biggest service. And that solution provider means one is engineer or a scientist, both. Engineer is relatively different because it's application of solution, and by application of solution you have to find further solution, and solution comes from application of analysis, and that analysis is job of engineer. In profession, analysis is done everywhere. In home, analysis is done, in family, analysis are done, in society, analysis are done. Those analyses are different nature. They are social culturist analysis, there are cultural analysis. There are different type of analysis which are not related to profession or expertise. Those are related to rituals and all others. But what I'm talking, that's analysis related to nation, related to the economy, related to various other issues. Those must be very well understood. And if you don't understand them, you take them, easy, it's easy, we'll do it. When you consider easy, we'll do it, I think that's the point where we make mistakes. We easily take it that it is easy. We without understanding, without comprehending what could happen, what could adversely affect our acts which you take. If you don't understand, it's like you just design something without even knowing where it's going to be erected, without even knowing what forces would impose on them. How can you design? That's what means you need complete information, and that information comes from studies only, practical studies which are based on inspections. Just like we refer to in that statement, inspections to be conducted, questions to be raised, and then identify problems, and then you can say find solution. That's where we say that we have to, and that system which I said, a method is very common, or procedure is very common, because everywhere you will find methods, everywhere. Maybe these are not written somewhere sometimes, but they say, I know this, I can do this, don't worry. Means those people, by virtue of experience, they can do something. That's also a form of methodology, because maybe they are not given in writing. A person cannot give in writing, but in his mind it is, in his experience, in the hands it is. So if that person performs, then somebody else can write method statement based on that activity, and that method statement can be formally devised based on observations, how this person reached this. This person did not write, but what he did, we can convert that to method statement for reference. So when I say method statements, it is your own device, it is your design, it's your experience based statement, and maybe for at least that project or for further projects, that could act as reference document or resourceful documents, not just students document, but documents everybody can refer to. Everyone in profession or on the project, everyone who is authorized to refer to those documents can refer, from lowest level officer, lowest level personnel to highest level director. Whoever is involved with that, that is where you can say that method is used, and that methodology is I should not say methodology, because there is no science in that. It is just procedure, means you cannot call it methodology, but people call it methodology in writing. Actually, that is method statement, and something you are going to do, how you do, what is background, why you want to do that, and what are references for that. That's a simple format you have to use, and write that, so that document which is based on professional documentation, can say that is professional document, because it is agreed by few parties, means agreed by contractor, it's agreed by consultant, it's agreed by owner, at least by consultant, and that agreement based on scrutiny of that statement. Okay, fine, this statement is clear, but information, very much particular information we require for this activity. This method gives in tuning to requirements, means the requirements are no different than what this method is talking about. If this method speaks something, it's fine. We can say, okay, method is good, and we stand on this, we'll implement this. That implementation is really worthy, it's very important from every point of view. That's why method is very important document. If your method is correct, is conducive, is limited to actual work, and that complies with all requirements, like specifications, like codes, and whatever drawings you have. If this statement involves and complies or conforms to all these what you can say, expectations, and that method is refined one, and when you work on this method, probably you will not find many problems, but if some problems come also, you can immediately solve them and understand the test was missed somewhere. That is called method statement. It's very specific writing, specific decision, and it's not written by an ordinary person, but experienced discipline engineers or managers who must have experience on sites. If it is site related, they must experience of somewhere else if it is that related. But when I'm talking of method statement, I would talk of site requirements, not of something else. Because after all, project is our everything. In engineering, project is project. We cannot defy project just because you want to go out. So my point of view is that method statement writing is very important, and that writing you can do only when you understand how work is done in field, and only then you can say these people are studious. So my point of view in statement is the method statement is very important for every important activity. Do not rush for work, but for making a decision through method statement what you are going to do. And that should be complementary to requirements. It should not be simply because you want to do that or your boss wants to do that. It's because of what is required. Your method statement shall stand good only when it meets all requirements. And there's third party inspection as well, consultant inspection as well, your own inspection. So your proposal of method statement should match with those requirements and with those questions raised by your consultant or engineer. That is only basics of method statement, because there are four parties, three parties, and there are three ways to solve. So it's better to contemplate one time and solve it in form of statement. And that could be a repetitive one. If you do one item, then you do next item, similar nature. This will work there as well if you think so. So method statement is a document which contains complete technical requirements, and those are very important because if you make mistake, although it's not expected that you make mistakes in method statements, if you are experienced one, if you are not experienced one, you cannot write it because you don't know what to write, how to write until you have your legal backup or experience-based backup. If you don't have that backup, there is no way that you can write method statement. So only purpose of method statement was that. I'm not finding people writing method statements before doing work. They just want to jump onto working without knowing, without understanding each input and expected output. That's the drawback, I can say. Quality system must be regenerated, and that regeneration can happen only when you have people like him. It's easy to criticize. My point is not to criticize anybody because my objective is different. It is easy to criticize, I can say, but I am not saying that because I know people are well educated, professionals are well educated, they have a reasonable level of degrees and then experience, and someone raises some point of patent, means point of elections do not appear, where something appears, something doesn't appear, some fear in creatures, no fear in creatures. This goes on like this. So point here is, if you want to get something in field or quality related, then you have to keep yourself confined within accepted level of construction method statements. And if you can do that, and you are so mature now that you can write, the writing of statement is not very easy. It's a very difficult task because you are late, you don't have time. And then you don't have time, you can say you are very busy, but remaining very busy is indicated by your completion of activities. And just like that paper I brought and you saw that paper, you analyze that. So we have to understand what we could not. Now, based on method statements, this quality system can be drawn according to SL. SL, AnnexSL. Last time I shared with you this document you are watching, reviewing on screen, that is AnnexSL ISO 9001 2015 Quality Management System, Company and EPC Contracting Facilities and Building Construction. This AnnexSL for this company plus EPC contracting facility building construction. And we have gone through many pages of this document, and many pages we have gone through. You can see that we gone through these many pages last time. And here is clause 1, then we had gone to clause 2. I am sure we had gone to. I am just browsing for you so I can see what you have talked of or done. You can see components of some facility we refer to. I'm just moving fast because the only definitions of it, or components of that project. I think I was on page 37 somewhere or more. I actually don't remember. Let me see where I was. At this moment, I'm going fast. Normative references we had covered, and also clause 3 control references. We reached somewhere. Supporting says supporting surveys we did. Okay, we say we start here. We is doing supporting executive. We did many points we covered. But let us have a look what we discuss here. Very important point we gave here in discussion. Supporting executive references, it's called, which are taken surveys, land and bathymetric, battery limits, demarcations, excavation, all types, soil testing, exploration, on site all ranges, soil improvement all ranges, blinding concrete protection, waterproofing, below ground and above ground, cast in situ concrete, formwork all types, reinforcement fabrication, reinforcement placement, precast, pre-stressed concrete if included, concrete class, reinforcement grade, structural steel, soil backfill, piping all types, concrete block walls, roofing all involved types, plastering, rendering, flooring all types, including raised one, blast doors, windows, ironmongery, kitchen including messes, wet areas, finishes all type, special items depending on requirement, performance testing and commissioning, design, estimated quantities, issued for information drawings, designs drawings, issued for building permit, drawings if relevant, generally on plant areas buildings permit would not be required, issued for construction drawings, revised drawings when equipment is finally decided, giving complete technical details, national annexes, nationally determined parameters, published documents, and all another necessary definitions. This is where it is. Let us briefly represent again. I talked of survey lands and bathymetric means talked of surveys, geographical survey of that area, which may be many kilometers by kilometers, 3 kilometers, 2 kilometers by something. That's geographical area of the plant, which must be known fully before doing anything. What is where? Maybe some electrical line is passing through there, or whatever, stream is passing below, or maybe some services we don't know. So surveys are required to be done, the land surveys and bathymetric surveys if related to where sea exists. Then we can say battery limits. We have to mark battery limits of plot, where is our area, where we can move power plant site, and that is important one. We have transport, we can bring people to site, take them back. So we have to say battery limits. All where we say this is our plot and we can batter it, we can demarcate it, we will not go out of that. It could be extensive one. And excavations, we have to do all types of excavation. We should know what type of ground exists, what are state of grounds, and this could be of whatever type. We are taking your sea transport is not allowed, but sometimes could be depending on the requirements. You say definition. This is excavation of all type. You have to understand how to excavate in sandy soil, how to excavate in gravel soil, how to excavate in washing. So, excavations, all types we are talking. So, excavation in pit, excavation in waterlogged area, excavation in sandy soil, excavation in clay soil, excavation in rock, soft rock, medium rock, other rocks, and excavation by home, or you can say by servant, excavation by that, maybe small or big. Excavations of all type, excavation in water table area, excavation dry area, excavation like this. Now we have to be careful about excavation. With excavation is very big responsibility in some areas. Though it's plant area, maybe we not find that problem, but otherwise it's very big responsibility where underground services run or what happens. I'm talking of all actually, not talking of this project only. I'm talking of all services that could be extract available in this. You may have to excavate in rocky, yeah, you have to excavate in waterlogged area, you have to excavate in soft soil, you have to excavate in clay soil. You do not know what is that. So you have to conduct surveys. Simply excavation in all types. Every excavation has different story, different method. Then soil testing, exploration on site, all field. Soil testing. Then whatever excavation you do, a separate story. Then soil testing, exploration site, all danger is linked to same. You have to conduct soil analysis by soil testing, which is very important item. You cannot avoid this. And exploration is a must, without which we cannot know what is below soil to how many meters. Minimum 10 meters is mandatory according to investigations, because foundation goes to the 1 meter below, it's to 9 meter depth is available, which can compare that. Now we know soil testing results. You can see how far you have to read that report. If you understand soil engineering, you must. Otherwise, this report will not tell you anything. If you have taken this from international laboratories, if you have taken only from soil investigation is father of your work. You may say that. It would tell everything about below what's course, how extensive it is, how you are found. When we conduct soil, we have to keep many factors in mind. It's not simply what I say you do it. We have to think what sort of project it is, how far its foundation could be, and how could it impact its future. These points must be kept in mind, and while project is very big, we should not leave any report Very simple. We should go to police and ask for details. And police will give you details, tell them explanations. Once they give you, and then if we move further, if we move a little further from the soil testing and we go further on to how to handle this, it's very important point. Very, very important point. How to handle this. It's always easy to speak. Soil testing gives a report and we have to take that into consideration If that laboratory is professional, if that is practical engineers, if that laboratory, they have a comprehensive report with complete range, full range of testing. And recommendations, of course, will be what the job is not recommending, the job is just advice whether there was any error respectively following. Now, when we survey soil, we investigate soil. It's also true that no soil is uniform in texture, in its composition. There will be different variations in that water contents, in that chemical in that. But most important is strength of soil, its bonding strength, its direct strength, shear strength. That's very important. So what we do, for example, the yellow soil like there. It was somewhere and it is not understood what sort of soil is there, but reports come from laboratory and we understand what boreholes speak, what others speak. That's very important point. We call borehole logs. That is not something that we cannot understand. We understand by reading so many meters down what is strata and then further down what is strata. And we get bearings test reports as well. And in some cases shear strength we get, or in some cases different report. We also get thermal resistivity or electrical resistivity or electric corrosion effect. Everything that soil report can tell us about. And it's good one if you know your soil what it is. It also says clay base or lime base or it is sand base. And purity also does not mean that it's very good soil. What conduct it would give, how should conduct means conduct with not personally with me or with you, but with circumstances, with family of crops. What status when crop is delivered or not delivered? Do you maintain status? That report I'm talking of, I wanted to show you something that I should. I missed last time. I wanted to show that report as well. It's a very important document. It's available. I'll try to find out for this given time. We will go. I'll show you this document and soil improvements after this. And soil improvements we conducted. That's very important point we have to take into consideration. Soil important, soil testing, soil improvement, that is very much required and we have to know it, we have to understand it. And I'll find out that, just hold on, I'll find out it. And meanwhile, I'll be back in a few minutes. I have to go to terrace just for something because I have to walk also for 2 minutes because of my leg problem. Oh. back again talking to you guys. Sorry, was talking about the soil. Let me see if I can show you soil report. If I can get that one. Let me see if I can easily find it out. Those soil reports. Possibly, maybe, may not be. I cannot say. That soil report I'm trying to find. Let me see. Soil DB, soil. The facilities, sheltered engineer design, soil, no, it's not in this. Reports, maybe. Soil report, where it is. Let me see if it's where. General. My problem is I format many things. So many files are there, so many files and it's sometimes difficult to find because I'm not opening those files daily. AnnexSL, Six Sigma. SL. Resume 1000 contracting this that. It's not here. So where is this general records? Data transfer. Such important information I forget. Lithosphere. My mind is rubbish. See, I've seen this many times. My mistake, I should have been ready before talking to you. The URL is there in that, but I don't have to go to URL. Resources. ACI, CV share. Soil investigation. I got something, I think. Yeah, yes. Something I have here. I'll show you that. Okay, alright, something I have. Thanks, I got something here. I'll show you something here. Relaxing file report. That's a sub report. Something is better than nothing, and you can see that it's coming in. Yeah, this one report. I was talking of soil reports is one of that, and we are going to just have a. So this is your soil report. You can see. This is a very old report, of course, but old doesn't matter. See. This is 2003 geotechnical investigation for whatever project. You just interested in what actually it contents, what contents it has. That's more important than something else, you know. And Rana, good morning. And Mr. Chaudhary Raju, good morning. I've seen just now. Well, it's okay. Just trying to show this report. Purposes of study, scope of work, that's one part. Purposes of study and scope of work. Then project description, site description, prevailing conditions, general geology of area, field exploration and testing, in which is drilling, sampling from boreholes, field testing in boreholes, excavation on trial pits, sampling from trial pits, field testing in trial pits, field density test, soil electrical resistivity testing, field soil thermal resistivity testing, laboratory tests, codes, surface and subsurface conditions, ground materials, materials physical, mechanical and thermal properties, materials chemical properties, sulfate content, chloride content, other chemical contents, oil and grease hydrocarbons, pH value, then groundwater and cavities, general discussions for choice of suitable foundations, footings on sand, general consideration of settlement, consideration of bearing capacity, choice of type of foundations, conclusions and recommendations, foundation depth and type, tank foundations and hydrostatics testing, allowable bearing pressure, foundation settlement, soil design parameters, foundation subject to vibrations, general consideration in designing dynamic basis, subgrade evaluation and pavement considerations, objectives, method of analysis, subgrade properties, recommended type of pavement, general considerations, earth pressure parameters, site preparation, clearing and grubbing, cut and fill side slopes, protection and monitoring, earth dikes and beams, drainage, dewatering, excavation method and excavationability, excavation side slopes and or lateral support system, backfill material and compaction criteria, structural fill, general fill, borrow sources, soil resistivity and corrosivity, foundation concrete, tectonic of southeast region of peninsula, seismicity and earthquake area of southeast region of Arabian Peninsula, ground shaking and free field ground acceleration, liquefaction, densification, swelling and shrinkage potential, inspection during foundation excavation, list of figures, major faults, seismicity effect, earthquake area, average values of maximum acceleration and rock, list of tables, existing ground level, plant coordinates, UTM coordinates and depth for all boreholes, existing ground levels, plant coordinates, UTM coordinates and excavated depth of the trial pits, proposed foundation level, foundation type and allowable bearing pressure, representative compression wave and shear wave velocity, summary of CBR and modified Proctor, earth pressure and soil parameters, soil corrosivity versus resistivity, then table of location of boreholes. Now appendixes are location of boreholes and trial pits, logs of boreholes and boring and trial pits, then legend to logs of boring and trial pits, logs of boring, logs of trial pits, generalized subsurface profiles, field density test results, soil electrical resistivity test results, soil thermal resistivity test results, standard penetration test results, laboratory test results, grading curves, Setterberg limits and soil classification, moisture content test results, moisture density relationships test results, CBR test results, lab permeability test results, laboratory thermal resistivity test result, oil and grease test results, chemical test results for soil and groundwater. Then of course report starts now, and that's where it says this title is Abu Dhabi Gas Industries Limited engaged in methods such and such to carry out front end engineering design phase of OGD. So it's that one. Certain references are given here. Certain you know, project names are here, nothing to do with that now. Purpose of study is more important. Purpose of study is to determine determine surface and subsurface conditions at proposed project, and and physical, mechanical, and chemical properties of investigated ground in order to provide a structural engineer with sufficient information for design of most suitable and safe foundation. And scope of this work consists of following: collecting information and maps particular to site, such as public services, site plan and land use maps; making inspection visits to site to collect information about present land use, surface topography, geological features, and subsurface and surface drainage; then drilling total of 28 boreholes, in situ testing and sampling of disturbed and undisturbed samples; excavation of 3 trial pits, carrying out 14 field density tests, carrying out 18 electrical resistivity tests with 0.75, 1.5 meter, 2.25 meter, 3 meter, and 4.5 meter spacing, carrying out 6 numbers field thermal resistivity tests, carrying out physical, mechanical, thermal, and chemical laboratory testing as follows: and soil samples, particle size analysis, materials passing number 200 C, moisture content, Ethelbug limits, modified Proctor, California bearing ratio, lab thermal resistivity, permeability, chemical analysis including determination of chloride content, sulfate content, pH, calcium carbonate and magnesium, oil and grease and petroleum hydrocarbons in groundwater; chemical analysis including determination of chloride content, sulfate content, pH and magnesium, oil and grease and petroleum hydrocarbons; performing engineering analysis of field and laboratory finding, developing conclusions and recommendations for design and construction, reporting. This was scope. This was scope of work. You see how long scope of work it is for such a project. And it's very important part of particle size, then materials passing 200 numbers in analysis in and oil analysis in groundwater, whatever analysis, chemical analysis, to know chloride content, sulfate content, pH and magnesium, oil and grease and petroleum high carbon, performing engineering analysis and developing conclusions reporting. Is what is that? The description of project. If you go on like this, part one, part two, all, you'll find a lot of information, weather conditions about the, then what are the other conditions is given: temperature is high and seasonal changes and high humidity and like that, strong winds, condensation at night, wind bonds are like this. I am just trying to show you what report is all about. General geology of area, how it is, some history is given, though it's not very much important. Let's say drilling, how it will be done, what was done, this drilling was done this year, existing ground levels, plant coordinates, existing ground levels, plant coordinates, and drill depth for whole boreholes. So this is borehole reporting here. What's east and west in coordinates, and existing ground level is this, and drilling depth is this. And this is the table of continuation is this. Boreholes 28 numbers say, then this all going on. And you can say field testing of boreholes, what was done. Then you can say existing ground levels, plant coordinates, existing depth of trial pits. It's also trial pits, and then we can say from trial pits this is report here. Also soil, field density, soil activity, electrical and resistivity testing as well as air. You can say, yeah, laboratory testing, all references in ground materials, surface mechanical and thermal properties, materials chemical properties, and you can say pH value, all those are there. General discussion for choice of suitable foundations, that is discussion here. Considerations of settlement, and likewise consideration of bearing capacity, then type of foundations, and recommendations, foundation depth type, and then so many other functions given, tank foundation hydrostatic testing, of course here. And this another one, see, this is details that are of those boreholes. This is very important, SPT value, depth, bore number, this, all these reports are given here. So a lot of studies required to be done this, that's what we can do. All these reports are going very fast. You can see this all going here. All this, I'm trying to show you its contents, of course. Soil investigation reports tell you all this. And it's very much technical document which must be clearly understood. You can see this representative compression wave and shear wave velocity, foundation subject to vibrations, general considerations in designing dynamic basis, then subgrade evaluation, pavement properties, and CV analysis, metal density, CBR, all those full range report is here. Then you can say here this, such as tile pits, accumulation type payment, what payment you need. Just you can see selection of design value, general considerations, earth pressure, and then so the formula here, result and lateral force, that is P is lateral force, right? You can say h square vertical height of fall. Well, this is something which we'll see later on, now, not now. You can say earth pressure parameters given this. Side preparation, clearing and grubbing, cut and fill side slopes, earth dikes and bumps, drainage, diverting, excavation method, excavation side slope, and that is 7. Then backfill material and compaction criteria, structural fill. This backfill is very important from every point of view. It's not only in this report, but just the happens says backfill material compaction criteria. Most of materials which will excavated from site consists of dune sand. This concept of dune sand. These materials will probably be satisfactory for backfilling purpose in confined areas. Suitable surface protection shall be considered. Dune sand materials were used in open areas. So then structural fill is very important. But in this case, structural fill under foundations is talking about is required. Metals to be used shall be free of organic contents or material. Other deleterious substances, fluoride content shall be less than 1%. Chloride content shall be less than 1%. Others are free of organic, no organic material in that, no material. Other deleterious substances, chloride content shall be less than 1%, and sulfate content shall be 5%. Provided project specification. And well-graded granular mixes, which will no practical size, no particle larger than 75 mm. At least 80% of metals are smaller than 19 mm in size. 80%. This means elongation, 80% of metals are smaller than 19 mm, which is bigger than 19 mm, or you can see 20%. Not more than 20% you may say elongation, though it's taken nowadays 30% elongation, but it's what it says, material Metals passing through sieve 200 shall be less than or equal to 15%. Plasticity index less than 6. Metals under foundation compacted to 95% of maximum dry density as obtained by modified Proctor ASTM 1557. Plate bearing tests be carried out as quality control measure to verify required allowable bearing pressure and total settlement criteria under foundations. Then general fill, this was a structural fill, talk of the general fill. What is difference now you will understand. Materials to be used for general backfill. Purpose shall be selected fill composed of sand and granular mixture. Sand or granular mixture free from organic matter. Other deleted substances. Plasticity index of backfill materials shall not exceed 15%. Shall be spread in lifts not exceeding to 25 centimeter in uncompacted thickness and moisture conditions to optimum moisture content. Uncompacted to vary to dry density not less than 95% of maximum dry density as obtained by standard Proctor test ASTMD 698. Borrow sources. Following borrow materials are available: dunes and gatches, grave sand, mixture from Suhan, Alain. So these are different sources mentioned. Soil resistivity and corrosion, which is a soil corrosion and resistivity report. And what we say is there foundation concrete. What about concrete set? We'll go through and then you can say within soil modified or confirmed design recommendation shall be responsibility of design or something. And the tectonics of southeastern is tectonic status and seismicity and earthquake area of southern east region, like that it is given complete one. And these are areas geographies drawings are given. What about areas of central and then this is various locations. Then this is a ground shaking and free field ground acceleration. It's very important here, you know. So it says intensity of future earthquake ground motion project area will depend on. I was telling about project area, just reading for your reference. The pound distance from earthquake epicenter, magnitude of earthquake and soil response characteristics according to information presented about tectonics and seismicity of southeast region of Arabian Peninsula. It can be concluded that within anticipated lifetime of project, 50 years say the maximum possible Richter magnitude future earthquake, 6 minimum distance of 100 kilometers from project, approximate maximum free field ground acceleration can then be obtained from curves show relation between epicenter distance from causative for them and maximum acceleration for different earthquake magnitudes such as relationship present in figure number 4. This figure is published in report number this earthquake engineering research center University of California Berkeley 1972 acceleration for earthquake in western United States by P. Scaverill and H. Bolton seed. This is also given now. Liquefaction. Liquefaction is very, very important phenomenon to understand, and you know it defines the soil liquefaction as a phenomenon in which saturated, loose, cohesionless soil, not cohesive soil, cohesionless, I can say. Soil liquefaction is a phenomenon in which saturated, loose, cohesionless soil are subject to temporary but essentially total loss of strength. You know, liquefaction means a phenomenon which saturated, loose, cohesionless soil are subjected to temporary but essentially total loss of strength induced by severe earthquake. During earthquake, you can say soil liquefaction defined as phenomenon is saturated loose cohesionless soil are subject to temporary but essentially total loss of strength induced by severe earthquakes. Significant factors known to affect liquefaction potential of these soils are characteristics of material such as grain size distribution and relative density, initial stresses acting on soil, and characteristics of earthquake such as intensity and duration of ground shaking. So liquefaction uh, means there is, you can say, strength loss of the strength induced by earthquake, maybe temporary loss of strength. Total is total loss of strength, temporary but essentially total, that is loss of strength in soil, that's liquefaction, and in cohesionless soil it is. Then you can say there's another one, all those drawings. Densification, you know what is densification? Compaction. So strong earthquake, ground shaking could cause densification of a loose, dry sand resulting in subsidence of ground surface. This would have negligible effects on more deeply buried structures. However, since site be properly prepared and filled with selected and engineered materials, risk of any structural damage is considered negligible for all types of structures. Collapse is engineered material. Says that this however this would have negligible impact affecting more deeply buried structures. However, since site will be properly prepared and filled with selected and engineered material, risk of structural damage is considered negligible. Collapse is the collapse potential, swelling and shrinkage inspection during foundation excavation, inspection during final excavation. Recommendation given this project are based on the assumption that subsurface materials and conditions do not deviate appreciably from those disclosed in borings. However, there may be conditions pertinent to site which were not disclosed by investigation due to limited number of boreholes, which therefore could not be taken into account. In such cases, our and soil and rock types, clay, silt, sand, gravel, cobbles and boulders.